Lecture 22, Limit and Continuity of Multivariate, Part 1. First we discuss the limit of one variable. So as we know, the limit tells us the value that a function approaches as the function input get closer to some number. If we see that graph, so that is what this is a function graph, says fx, and there is a point A when x approaches to A either from the right side or from the left side, then the function is get closer a number, that is L. So we can say the limit at a point A of the function fx is what? L. The definition, the limit of the point, mathematically we can define a function f has a limit L at a point A if for all epsilon is greater than 0 there exists a delta such that fx minus L mod is less than epsilon and implies x minus a mod is less than delta. Means when the x is approaches to a, then the function is approaches to, or we can say closer to a number, that's a L. So we can say the limit of that function at that point is L, or we can sometime we can write as limit when x tends to a fx we get L. So the limit of the function at point A is what? L. When does the limit exist? So when we say the limit is exists, so limit exists, suppose a limit x tends to A and fx exists only if both sides of the limit exist and are equal. That is, the limit x tends to A fx is exists if the left hand limit, that is when x approaches to the left hand side, and the right hand limit when x tends to A plus, we get a number L. So we can say if the left hand limit, that is a left hand limit, and sometimes that's a right hand limit, both are exists and equal, so we can say the limit of the function at that point is exist. Now look an example to understand the concept of the value of the function and the existence of the limit of a function. So we take a function, that is fx is equal to x square minus 1 upon x square minus 1. So we have to check the value of that function at x equal to 1, and is the limit of the function, that function is exist at x equal to 1 or not. So first we find the value of the function, so we just put x is equal to 1 in that function fx, x square minus 1 upon x minus 1. So function is not defined at that particular point because 1 minus 1 upon 1 minus 1 we get indeterminate form, that is not defined. So if you see the graph of that function, that one, so you observe that at 1 the function is not defined. Now we check the limit of that function is exist or not at x equal to 1. So for that, for existence of limit, first we find the left hand limit and then right hand limit. So the left hand limit x tends to 1 minus, that is fx. So if you put 1 minus epsilon, or we say 1 minus h, so we get 2, the left hand limit. And if we approaches x equal to plus 1 in that function, so we get 2, because when x approaches from the right side we get approximately the value is 2, and from the left side we get the value, that is 2. So we can say the left hand limit and the right hand limit both are the same and equal, so we can say the limit when x approaches to 1 is 2. So here we say the limit of that function is exist at x equal to 1, but the value of the function at x equal to 1 is not defined. So hope you understand the concept of the value of the function at point and the limit of a function at a point. Continuity. A function fx is said to be continuous at a point x equal to a if the left hand limit and the right hand limit and the value of a function at that point all are equal. Means the left hand limit, let's say we get fa, the right hand limit we can say fa, and the value of the function when we replace x with a we get a function fa. If these left hand limit, right hand limit, and the value of the function at point all are equal, then we can say a function fx is continuous at particular point A. So here you have to note that when the function is not continuous, if suppose we say this is a point and this is a function, if the function is break somewhere like this, so that function is not continuous at particular point. This is a discontinuity of point of discontinuity, and in that case we can say there is a hole between that particular curve. And the second, if the function has a jump, says this is the a point, and the function is like this, in that case the left hand limit and right hand limit all are different. Or when the function is vertical asymptote, so this type of function is what is not continuous, they are says discontinuous functions. Now we discuss the limit of for two variable. So as we define the limit for the one variable, similarly we can define the limit for two variable. On the difference is what we use here, we use the different approach, because in two variable it is difficult to define the left hand limit and the right hand limit. So here we use the concept of different paths, because the right and left hand limit and the right hand limit on the surface is defined difficult to define in the space, 3D space. So first I'm trying to explain the definition. As x and y approaches to AB, when x tends to A and y approaches to B, the limit of the function fxy is say a number that is capital L. And if the limit from all the path approaches to AB, means whatever the path we use to reach AB is exist and are equal to some number that is L. So we can say when the limit x and y tends to AB, the function fxy we get L. So the limit of that function at point x y is equal to AB is L and is exists. Now we discuss the existence of the limit. So here I'm trying to visualize by 3D figure. Here let's take a point, says that's a point, says A B on that space, on that particular space. So and now we have to check the limit of a function f x y at that point AB, or we can say on that surface at AB is exist or not. So as you know, here it is difficult to explain the concept of right hand and left hand limit, because the point is in that space, 3D space, so it's difficult to define the left or right of that particular point. So uh, therefore we can say we use the concept of the different path. Here to reach that point we use a different path, and it can be line, means it can be a line, a straight line, or it can be a curve. There are so many paths. So here whatever the path we choose to reach that point, we get a definite number that is L. So we can say the limit of that particular function fxy is exist at that particular point. Now remember the function of one variable. If the function was continuous, then we can say the limit x tends to c fx, we get fc. Means the left hand limit and the right hand limit at that point and the value of the function at that point is equal. So we can say the function is continuous. In the same manner, we can say the same is true for the function for the two variable. If function is continuous, then the limit xy tends to ab, fxy we get fab. Here again, if the limit of that function is exists by using the different path and the value of that function at AB is equal, then we can say function is continuous. So function is continuous at point if the graph doesn't have any hole or a break at a point. So by graphing we can easily define the function is continuous or not, or is helpful to explain the graph is continuous or not in for two-dimensional function. Now here is important, if the function is not continuous at particular point says AB, this doesn't mean that the limit does not exist. We need to consider the approaching AB from the different path. So if function is not continuous and we are not sure, here some common path to consider when the determining the limit of the function of two variable. So these are some standard path we are using, says x equal to a, y equal to b, or we take a path y is equal to x on a straight line, y is equal to x square, we take that path. This is a curve, and x equal to y square. So we can take any one of these path and check the limit is exist or not. Now look at an example to understand the concept. Determine the limit of that particular function when xy approaches to a point 1 1. So here we have given the limit when xy approaches to 1 1, means when x approaches to 1 and y is approached to 1, then the limit of that function is what? So we just directly substitute the value of that x and y in that function. So here what we do, that we have to find the limit x y approaches to 1 1 fx plus 2y x plus y. So first we apply the limit y tends to 1, so we apply 4x plus 2 into 1 upon x plus 1. So we write 4x plus 2 upon x plus 1, our limit x tends to 1. Now apply the limit x tends to 1, so we write 4 into 1 plus 2, 1 plus 1, so we get 6 by 2, that is 3. And the similar way, first we apply the limit x tends to 1, then y. In that manner we get y tends to 1, 4 into 1 plus 2y upon 1 plus y, so we write 4 plus 2y upon 1 plus y, and limit y tends to 1, so we get 4 plus 2 into 1, 1 plus 1, that is again 6 by 2, we get 3. So we can say the limit when xy approaches to 1 1 of that particular function 4x plus 2y x plus y, we get 3. So the limit of that function at that point is 3. So if you see that diagram, so here when the limit is approaches to 1 1, we can say somewhere here, so we get value 3. So limit is exists and is 3. Now take one more example. We have to determine the limit of that particular function at x and y approaches to 0 0. You can see the graph of that particular function. So here that is the 0 0 origin point 0 0. So we have to find the limit at particular point. Now if we apply the limit on that this limit on that particular function, so we get an undetermined form, that is 0 upon 0. So for that, to find the limit of that function, we use a different approach, means we consider different path. So first we take the path, that is y is equal to x. When you take the path, you have to remember on that particular path, this limit should be exists, means when we take y is equal to x, so it passes through the origin. So now if we take y is equal to x, so apply on that part, so we write limit x tends to 0 0, that is, and x upon x square plus x square, we just replace y with x. So here limit x tends to 0, x square upon x square plus x square, so we write limit x tends to 0, x square upon 2x square, so we get 1 by 2. So we get a limit 1 by 2 when we take the path y is equal to x. Now if you take the path y is equal to, take y is equal to minus x. So what we get? We get limit x minus x approaches to 0, 0, and we replace y with minus x. So we write x minus x upon x square plus x square. So we write limit x tends to 0 minus 2x square upon, sorry, that is x square minus x square upon 2x square. So cancel them, we get minus 1 by 2. So in that case, the limit is what? Different. So we use the different path, we get the different limit, and when we use the y equal to x, we get a different limit. So we can say the limit of given function at the point 0, 0 does not exist. Now, in the previous example, I'm just changed the limit of that particular function. That is, when xy approaches to 4 and 2, we find the limit of that function. So here, if you see, that's suppose x and that is y. So if we take that's a 2 and we take this is 4, so the point 4 and 2 is somewhere. Now we have to find the limit. So we just apply we take the path. First we take, because we have on that path we have two choices, either we go with 4, 0, that is what x is equal to 4, or either on that way, that is y is equal to 2, that is 0, 2. So on that point we have two paths, y is equal to 2 or either x is equal to 4. So first we take the path y is equal to 2. Now put in that particular limit. So we write limit x tends to 4 and put the y is equal to 2 in that function. So we write 2x upon x square plus 4. Now apply the limit. We get 2 into 4 upon 16 plus 4. So we get 8 by 20. That is, we can say 2 by 5. Now if we take the path y, sorry, not y. Now we take the path, that path x is equal to 4. So if we take the path x is equal to 4, that path, so we put x is equal to 4 in that function. We'll write limit y tends to 2, 4y upon 16 plus y square. Now apply the limit y equal to 2. So we get 4 into 2, 16 plus 4. Again we get 8 by 20, that is 2 by 5. So here we can say the limit when x and y approaches to 4 and 2 of that particular function xy upon x square plus y square, we get 2 by 5. So limit is exists and is 2 by 5. So more example we discuss in the next lecture. Thank you.